morning, guys, or at least morning for me. We are working on our last chapter today. We have a shorter chapter. This is chapter 2b. I refer to chapter 2b as fancy derivatives. We've learned how to do derivatives. Now we're doing fancy derivatives. These are things that are a little bit more like specialized. They don't apply to everything we do, like chain rule, product rule, quotient rule. Those kind of things apply in any situation. These are more specialized branches. So if chain rule is definitely one branch, then this is kind of a spoke off of that. Not a lot of other things come from it. Important concepts, but not as essential to the learning process as chain and product rule and those types of things. All right, so today is one of those ones that we have left that's pretty good. Implicit differentiation. We have 4 sections left in the rest of the semester. Okay, so we have 3 weeks left. You got 4 sections only to learn. We are learning 3 of them this week. So a whole lot going on this week. Next week, we're going to do related rates, which is pretty difficult. It's going to take us some time, and then we'll review and then take a test. So, and be done. So that's where we're headed. If you have questions, ask me as always. Implicit differentiation might be a little bit longer lesson. The concept's easy. It's just a matter of practicing it more than anything else. So let's get to that. All right, so let me get going here. So when we do implicit differentiation, an implicit equation is an equation that has y in it, okay, or another variable in it for the most part. So when we take the derivative of y, so far we've said dy dx, like we've said y equals 2x. If I took the derivative, then dy over dx would be equal to 2, right? We've done that quite a bit. Well, technically, we are taking that derivative, what I just wrote, with respect to x, because we are figuring out the change in x, or think of that x like time, all right? Technically, what we did there, if I said y equals 2x and I took the derivative, what I would really write is 2 times, and then I'm going to, because the derivative of y is dy dx. Technically, the derivative of x is dx over dx, or the change in x over the change in x. Well, what happens if you had dx over dx? Well, those two things are the same, so you would just get dy over dx is equal to 2. So we haven't done that aspect, because why would we? It's just 1. But technically, every time we take the derivative, there is a certain variable that we are taking the derivative with respect to. And 95% of the time, it's x. So if I'm looking at this first problem, I'm going to take the derivative, d over dx, over that whole thing. I'm going to find the change in whatever letter I'm looking for with respect to x. All right, so the change in y is dy over dx. The change in x squared is 2x. And then I could write dx over dx, because I'm taking the derivative with respect to x. I took the derivative of x with respect to x. What's the derivative of 2x? Well, 2, and then the derivative of x is the change in x over x. Well, we don't need to write that because, or we don't write that normally, because dx over dx is just 1, and so this derivative would be this. That is the main idea of what we're doing here. All right. So we have not run into any issues with this yet, because every time we've done this problem, it's just been y equals. Well, what happens if it's y cubed? Okay, y is not just by itself. Let's look through that. Okay, so if I'm taking this derivative, the derivative of y cubed is going to be 3y squared. We treat it just like we take the derivative of x. But since we're taking the derivative with respect to x, I got to include dy dx. Okay, I'm finding the derivative with respect to x. So over here, 2x squared. Well, what's the derivative of 2x squared? That would be 4x, and I would multiply, technically, by the change in x over x. And then 5x. Well, what's the derivative of 5? And then what's the derivative of x? Well, technically, it's the change in x with respect to x. I won't write this again, okay? If I'm taking the derivative with respect to x, I will not write dx over dx, because that doesn't make any sense. So I'm really left with this problem. 3y squared, it makes sense, but we don't need it. dy over dx is equal to 4x minus 5. What we're going to do? Well, we want to get dy dx by itself. I'm trying to get dy dx by itself. So all I need to do is divide by 3y squared, divide by 3y squared. Boom. This is my answer. Dy over dx is equal to that guy. So what did we do? Well, we just took the derivative like we always do. The only difference is when I take the derivative of 3y cubed, I wrote 3y squared with dy dx, and then I got dy dx by itself at the end. Okay, a little strange, but you can do that. Don't let that be overwhelming to you. Let's look at number 2. Okay, number 2, find dy dx. All right, cool, I'm taking derivative. What's the derivative of x? Derivative of x is 1. I'm doing it with respect to x, so it's just 1. 2y squared, so it's going to be 4y, but I took the derivative of y, and so I need to include dy dx with it. 3x to the 4th, all right, I'm going to multiply by 4, x cubed, and then technically I would write dx dx, not going to. Boom, there's my answer. I'm getting dy dx by itself, so if I'm doing that, order of operations in reverse, I'm going to subtract 1, subtract 1. So I get negative 4y, dy over dx is equal to 12x cubed minus 1. I want to get this by itself, so what do I need to do? Divide by negative 4y, divide by negative 4y. That is my answer. That is what dy dx is. I got dy dx by itself. That's it. Don't make it harder than that. Let's try example 3. This one's the tougher one. Oh my goodness, I can't even draw a star anymore. Draw a star. That's how far I've been out of the classroom. Draw a star on this one. This is going to happen a whole lot. Oh my gosh, my stars are so bad. I'm crying inside. We are doing this one. This one's the tougher one. All right, put a star by it. This is what's going to happen most of the time with these problems. All right, so we're taking the derivative. We're taking the derivative of x and y. Well, it's not just x, it's x times y. You have two variables and they're being multiplied together. So to take the derivative of two things being multiplied together, guess what? We're using product rule. So we're going to do first times the derivative of the second. What's the derivative of y? dy over dx. Plus the second times the derivative of the first. Derivative of x is just 1. And then we're going to go minus. So we did this part. Boom, done with that. First derivative of the second plus second derivative of the first. Now I'm taking the derivative of y. Well, what's the derivative of y? The derivative of y is dy over dx. And that thing is going to be all equal to 2. Boom, there's my setup. And now my ultimate goal is to get dy dx by itself. So I'm going to move over anything that doesn't have dy dx in it. So that's this guy. X dy over dx. Minus dy over dx is equal to 2 minus y. So I moved over everything that doesn't have dy dx in it, but I get kind of stuck, right? I have two different things with dy dx in them. These two things are not like terms because one has an x and one doesn't. But I need to get dy dx by itself, and so we need to come up with a way of doing that, and hopefully what can we do? What do we think about here? Sorry, I got a text message threw me off. Well, I can factor dy over dx out of both of them. They both include it. So I'm going to factor it out, and then I'm going to be left with x minus 1. Well, why did I do that? Because now it's going to be really easy to get dy dx by itself. Sorry, I zoom in too much sometimes. What I'm going to do now is just divide by x minus 1. Divide by x minus 1. dy over dx is going to be equal to 2 minus y all over x minus 1. That is dy dx by itself. Okay, that is why we put a star here. When you have multiple dy dx's, okay, and you don't know how else to get dy dx by itself, we are going to factor it out and then divide by from there. Okay, that one's the trickiest one we'll do. So if you can handle that, you'll handle them all. Let's try another one. Flip to the back side. I'm going to change this number 50. I'm going to change it to 25 just so we can see this. Anybody know what this picture is going to look like? What is this picture going to look like? Well, this is a circle. X squared plus y squared equals 25 is a circle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Boom. That's a circle. You might have forgotten, but that's what it is. All right. So we're going to find the derivative. Know what a derivative does. It allows you to find the slope at a point. So if I'm fine, let's do it. Take the derivative of x squared, 2x. Plus, what's the derivative of y squared? Well, 2y. Oh, but it's got dy over dx because I'm taking the derivative with respect to x. What is the derivative of 25? And this is like the number one thing I screw up on these problems. The derivative of 25 is 0 because it's a constant. All right. Now I'm going to get dy dx by itself. So I'm going to subtract 2x. And then I'm going to divide by 2y. Dy over dx equals negative x over y. And I'm done. That's my answer. Negative x over y. Well, what does that tell you? It tells you the slope. If you pick any point on this circle, that would make this statement true. If I picked any point on that circle that would make that statement true, then my slope is going to work here. So for example, if I picked this ordered pair right here, that ordered pair would be 0, 5. If I plugged in 0, 5, guess what my slope is? It's 0. Okay. If I wanted to pick a point right there, like I don't know what that point is. Let's say is it radical? It's radical 20. No, it's not. It's radical 12 and a half, isn't it? Yeah, it's radical 12 and a half. Whatever. I have two positive numbers. Okay. When I plug in the same positive number, that ordered pair right there on top and bottom would be a negative number. This is why I had 50 originally, because I'm an idiot and I switched back and forth. Okay. But I could figure out what that number is. This would be 5, 5. That's what that ordered pair would be. If I plugged in 5 squared plus 5 squared, yeah, that gets me 50. Okay, that's what that ordered pair would be. If I plugged it in, it'd be negative 5 over 5. Well, guess what? My slope is negative 1. There's my slope of negative 1. If I picked one in this ordered pair right here would be 5, negative 5. So if I plugged in 5, negative 5, well, guess what my slope is now? It's a positive 1. That is what we're doing here. We're finding the slope at a point. By finding this equation, even though it's this weird circle-looking thing, it still allows me to find that slope. Okay, and that's the key to what's going on here. All right, let's try example B, or example 5, same idea. Nothing's changing. What's the derivative of 2y? Well, that would be 2 dy over dx, because I'm taking the derivative of y. 3x squared. Derivative of sine y? This is a chain rule question. What's the derivative of sine? Well, derivative of sine is cosine y. I rewrote the baby, and then I'm going to multiply by the derivative of the baby, dy dx. Cool. I'm going to get everything that has dy dx on the same side. So 2 dy over dx minus cosine y dy over dx is equal to 3x squared. I'm trying to get dy dx by itself, but I got two different things with dy dx in them. So what can I do? Well, I'm going to factor out. And then to finish, I'm going to divide by 2 minus cosine y. There's my answer. So again, we took the derivative. We needed a little bit of chain rule here. I moved everything that had dy dx on the same side. I factored out and divided. All right, that's the main idea. We're going to keep doing that concept again and again and again. Now let's look at it with this one. Now we're finding the derivative at a point, and this always throws kids off a little bit. They make it harder than it needs to be. This should be easier than the last problems we were doing, but sometimes kids make it tough. All right, let's do it. Example 6, 2x plus y all squared plus that thing equals 3. All right, let's take the derivative. So I need chain rule here. So I'm going to multiply by 2, subtract 1 from my exponent. I'm going to rewrite the baby, and then I'm going to multiply by the derivative of the baby. So what's the derivative of this baby? The derivative of 2x is 2. The derivative of y is dy over dx. Woo! Plus, now I'm taking the derivative of y. Well, what's the derivative of y? Dy over dx is all equal to the derivative of 3. Well, the derivative of 3 is 0. So there are two things you could do here. You could get dy dx by itself right here. but you don't want to. This is ugly. It's foiled out. You got to do some crazy stuff here. You'd have to divide and subtract, and it's not something I want to do. And so what I'm going to do instead is, I want to find this derivative at a point. I'm just going to plug in the point. All right, so look at what I got here. I've got 2 times 2x plus y times 2 plus dy dx plus dy dx. So what all I'm going to do is plug in my point. I got 1 and negative 1. So where I had an x, I'm going to plug in a 1. Where I had a y, I'm going to plug in negative 1. Now, I'm just going to do the math. So this is 2 plus negative 1. So this is 1 times 2 is 2. I'm going to distribute. So 4 plus 2 dy over dx. I'm going to subtract 4. And what happens if I have 2 dy dx's plus another dy dx? You have 2 of them, you got another one. Guess what? You now have 3 dy dx's. So if I want to solve this thing, all I need to do to finish here is divide by 3. Boom, that's going to cancel. My answer is negative 4/3. Okay, let me show you what this looks like. Just kidding, not going to show you that one. I'll show you the next one. All right, let's go to the next one. dy, so again, what did we find? Well, we found the slope at a point. The slope at this point is negative 4/3. It gets off a little bit because I was trying to make the problem easier, but we'll live with it. All right, example 7. We are finding this derivative. X cosine y equals 1 at that point. So let's take the derivative. Well, what do I need to do to take the derivative of x cosine y? I need product rule. First times the derivative of the second. So what's the derivative of cosine? Negative sine. We're going to rewrite the baby times the derivative of the baby. So that's first times the derivative of the second plus second times the derivative of the first. And that's going to be all equal to the derivative of 1 is 0. There's my setup. I could get dy dx by itself if I really wanted to. I don't. I'm going to plug in 2 and pi over 3. So I'm going to plug in 2 times negative sine pi over 3 times dy over dx plus cosine of pi over 3 is going to be all equal to 0. So I'm thinking unit circle. Boom. 6, 4, 3. That is pi over 3 right there. What is sine going to be right there? It is radical 3 over 2 times dy over dx plus cosine at pi over 3. Well, what's cosine going to be right there? That's 1/2. These two things are going to cancel. I'm going to subtract 1/2 over. So radical 3 dy over dx is equal to negative 1/2. So to finish that thing, all I need to do is divide by radical 3. Divide by radical 3. My answer is negative 1 over 2 radical 3. And you might say, Mr. Schwanekamp, in pre-calc, that would not be a good answer because you did not simplify the radical. Guess what? That's why I love calculus, because we don't care. That is a great answer. We're going to live with it. Okay, implicit differentiation. Okay, we're taking derivatives and plugging in. Let's try one last one. Write the equation of the tangent line and normal line to this ellipse at that point. All right, so let's go ahead and do that first. So y minus equals x minus. As soon as I read tangent, write the equation of the tangent line and the normal line, I'm doing this guy. Okay, this is going to be my tangent line. This is going to be my normal line. I'm guessing I might run out of space, so I'm actually going to move this thing over. Okay, I'm at this point, negative 1, 2. So I'm at negative 1, negative 1, 2, 2. There's my setup. All I need to know is the slope. If I know these slopes, I'm done. So write the equation of the tangent line and the normal line. So I need to know the slope. I need to know the derivative. So let's find the slope. Derivative of x squared is 2x. I'm going to need product rule here. And the number one mistake students make in all of implicit differentiation is this. We somehow got to put that negative with that x sign. Okay, so some students will go negative and then do product rule like that. That's not really how I work. I say this is the first part and this is the second. So I'm going to say first negative x times the derivative of the second plus the second times the derivative of the first. So when I say times the derivative of the first here, I need to include -1 because that's what the derivative of negative x is. It's not hard, but kids just forget it. Okay, plus the derivative of y squared is going to be 2y dy over dx. And what's the derivative of 7? The derivative of 7 is 0. There's my setup. Now let's do it. I'm going to plug in -1 and 2. So 2 times -1 minus -1 times dy over dx plus y. So that's going to be -2 because it's how it's set up, plus 4 dy over dx is all equal to 0. There's my setup. Now let's do it. -2 plus dy over dx minus 2 plus 4 dy over dx is all equal to 0. I'm going to combine some stuff. So -2 and -2. That's -4. I've got a dy dx and 4 dy dx's. So that's 5 dy over dx. I'm going to add the 4. Sorry, let's do that in 2 different steps. I'm going to add the 4 and divide by 5. Dy over dx equals 4/5. That right there is my slope. That's my tangent line. Remember what normal line means. A normal line is the opposite reciprocal. It's a perpendicular line. And so everything's going to be the same, but it's going to be a -4/5 right there. Okay? Implicit differentiation. The only thing we added was including a dy dx. Okay? That's it. Don't let it be harder than that. So just looking at what this is. So we graphed this line. X squared minus xy plus y squared equals 7. Here's that graph. We went ahead and graphed to the point -1, 2. And so what did we find? Well, we found the slope of the line, y minus 2, or we're doing it right in our equation line, y minus 2, and then we had 4/5, and then we're going to have x plus 1. Boom, that's the equation of the tangent line. That is the line that touches this weird looking ellipse at exactly one spot. Okay, the other thing we found was the normal line. So -5/4. What does that do? It draws a perpendicular line to that point, and it obviously perpendicular to the derivative. That's the setup. Okay, it's a weird concept, but I really like looking at this picture at the very end so we can see, hey, this is what's going on as we work through it. We are finding the slope at a point. The only difference is our equations are weird, and so our slopes are a little bit different. Okay, implicit differentiation, we're going to work on it for 2 days. If you have questions, let me know.